In the last part of this lecture, we will discuss the relationship between the four basic physical quantities of the circuit, that is, voltage, current, charge, and flux. As we know, if voltage and current are algebraic relationship, it represents a resistor. Of course, U is equal to R times I when they are linear. In general, for the nonlinear relationship between U and I, we have the incremental resistance delta I is equal to delta U, du di. Similarly, if charge and voltage are algebraic relation, we can define the capacitance. If they are nonlinear algebraic relationship, we can get incremental capacitance delta C is dq dt. Applying the viewpoint of duality, we know that the algebraic relation between the current and flux determines the inductance. We also got the incremental inductance delta L is d phi dt, d phi di. In the space of four variables, we have discussed the relationship of these two, and these two. Now the only missing relation is between these two variables. It's similar to the Mendeleev periodic table of elements. What we need the last link. In 1971, Mr. Xiaotang Cai put forward the mission circuit element. He called it memristor. And gave a lot of discussions on its properties. In 2008, the research team led by Williams of HP Lab found the implementation scheme of a memristor. Similarly, if there is a nonlinear algebraic relation between Q and phi, then delta M is equal to d phi dq. Because U is equal to d phi dt, and I is equal to dq dt. So we can write it as a form of d phi dt times dq dt equal to U over I. It means that the incremental memristor can be written as a form of U over I. So it is a resistance performance of memristors. In addition, through further derivation, we can find that the incremental memristor is proportional to the charge. That means the memristor has something to do with its previous current. As with the capacitor, its voltage at any time is associated with the voltage at 0 moment. So this is a part of its memory. Combining the parts of resistance and memory, here comes the name of memristors. Well, that's the end of this lecture.